welcome back. Today, the problem we'll be looking at is maximum product subarray. Given an integer array nums, find a contiguous non-empty subarray within the array that has the largest product and return that. The test cases will fit into a 32-bit integer, and the subarray is a contiguous subsequence of the array. Let's look at example 1. We have the input 2, 3, -2, and 4 in an array, and the output is 6. This is because 2 times 3 gives us the largest product. As you can see, if you multiply 6 by -2, it gives us -12, and there are no negative numbers on the right to offset that. Example 2, we have -2, 0, and -1. These two numbers are negatives, so we simply return 0 as if multiplied by any of those numbers, it'll simply return a 0, or if we take these two numbers, it'll be a negative number, which is less than 0. Hence, we return 0. So let's go to the whiteboard and have a detailed discussion about this. We have the input 2, 3, -2, 4 as an array, and we know that the output should be 6. One obvious brute force solution is to simply find all the subarrays and find their product. Once we have all the products, we simply return a maximum of them. But that would require finding all the subarrays, which will mean of n squared times complexity. We don't want that. What can we do instead? Well, let's have a thought experiment. Let's say if all these numbers before 4 are anonymous and we don't know what they are. So we will have an array that looks like this. There could be many numbers before 4. It doesn't matter. Let's say the array looks like this, but I do give you the maximum value so far. Let's say the maximum value so far is 7. And I also give you the minimum value so far. Well, let's say that's 2. If I gave you all this information and you arrive at the current element 4, what would be the answer? That's obvious, right? We simply multiply 7 by 4, that gives us 28. However, what if instead of 4 we have -4? What do we do now? Well, if it is -4, we don't want to multiply any of them. We don't want to multiply -4 by 7 or 2 because these two are positive values. So what we do instead is we simply return the maximum value, 7. And again, what if instead of a positive minimum value so far, we have a negative number? And notice how it is the minimum value that is negative because this number cannot be larger than this number. If this is negative and this is negative, we would want to return 8, right? We would want to return -4 times -2 instead of 7. So as you can see, there are a few cases that we want to take care of here. The first one being the numbers are increasing steadily. So if the numbers are increasing steadily, we simply multiply the current number by max val. If they're all positives, we get 28. However, if we have a negative number here, we want to see if there are any negatives in here. But as you will see in the code, instead of checking if each number is negative or not, we can simply calculate all 3 possible solutions and then find a max and min. But we do have positive numbers here, negative numbers that we have to take care of. Also, we have cases like 0. What if this is 0 here? If it's a 0, we don't want to multiply it by anything, right? We want to return the maximum value, which is 7. We want to keep track of our minimum value as -2 and not -2 times 0, which gives us 0 that is greater than -2. So what can we do? Well, let's see, right? As we iterate from the left to right, we have our values. So max val and min val. They will be initialized to some value, which is 1, because in a multiplicative process, we want to have we would like to have our variables initialized to 1, because otherwise, if we initialize it to 0, multiplication is not going to do anything. Once we have those values, and we want to have a result or output that we want to return, we can set this to none, or we can set it to the first element of nums, so nums 0. Then we iterate over the array for num and nums. For each of these elements, we want to multiply it by... Okay, so we want to keep track of all these elements, and a convenient way of doing this is to initialize some variable. We can call it values because it's going to hold multiple values. And what this contains is num itself, and what do we do here? We multiplied max val by the current number, and we multiplied min val by the current number, or we just take num itself, right? So vals will hold all 3 possibilities. So this would be num, or max value, times num, and min value times num. Once we have that, we need to update our max and min values. So max val equals to the maximum of the old value and the maximum, my bad, sorry. This would be going to be the maximum of this, right? Because minimum value times num might be a larger number than maximum value times num. So once we have all 3 possibilities, we simply want to take the maximum of them and update it. Similarly, do the same thing for min val, except this time you're taking a min instead. And once we have all this, we want to keep track of the result. So result would be the maximum of our old results and the maximum value here. Finally, we simply return result after the iteration. So let me reiterate what this is doing real quick. Essentially, we're trying to keep track of all the possible values at each iteration. We're trying to find maximum value times num. That would give us the maximum value if the maximum value so far is positive and the number is positive. If minimum value is negative and num is negative, then that would get updated as the value of our max val here. We also want to keep track of num, because in cases like 0 and 4, right, we would have num would be 4, max val and min val would be 0 because we multiplied in the first iteration. Hence, we want to save num equals to 4 because that would give us a max val of 4 over here. So let's go to the code walkthrough and see how we can implement this. First of all, we need to initialize current min and max. So current min equal to current max equals to 1. And then we have our result equals to nums 0. Once we have that, we simply do a for loop and iterate over nums. And we want to take care of all the possibilities, so we can do that. Current min times num, current max times num, and current min equals to the minimum of values. Current max equals to the maximum values. Then we update result that equals to the maximum of the old result and current max. Then in the end here, we simply return result. Try and run this code. Okay, got accepted. Now, okay, it passes all test cases, so it returns a success. That's it for this video, and if you liked it, make sure to like, comment, and subscribe. I'll see you next time.